Hello, I'm going to go over the answers to the Chapter 1 Honors Algebra test. Question number 1 says evaluate each expression. So the first step would be 5 squared is 25 minus, and then inside the absolute value bars we have -2 times +3. That gives me -6. The absolute value of -6 is +6. Plus 9, or -9 divided by 2 gives me -4.5. 25 minus 6 is 19. 19 minus 4.5 gives me 14.5. Okay, number 1, part B. Another evaluate one. So let's look inside the parentheses first. So I need to do the exponent first. -2 to the third power gives me -8, and then that would be plus a -3 times a -8 gives me +24. So I'm going to rewrite what I have. I have -1 plus 3 times 16 minus 5. Don't forget that 8 up here had been negative. So then I have -1 plus 48 minus 5. That gives me 42 as my answer. Okay, so let's talk about range and domain and whether this is a function. So right off the bat, I'm going to say, no, it's not a function because it wouldn't pass the vertical line test. So then let's talk about range and domain. So as I travel across the x-axis, the first x coordinate it's going to hit is right here at -3. So this is going to be -3 is the lowest or the smallest value. And then I travel across and I'd have another x value at +3. So -3 has to be greater than, or sorry, less than or equal to x, or less than or equal to +3. Or if you wrote it the other way, it's just a bracket, -3, 3, bracket. So now let's switch and talk about range. So range is going up the y, and the first y value it hits is 2 and 3. So it's between -2 is less than or equal to y, which is less than or equal to +3, or you have a bracket, and it's -2, 3. Okay, so this is the second graph that you were given to find the range and domain of. Right off the bat, I'm going to say, yes, it's a function. And then let's look at domain. Domain is your x values. So where do you run into the first x value? Right here at -4. So that value would be -4 for my x and +1 for my y. And then over here, we're going to 4. So this one's pretty easy. It's -4, 4, including them because they're closed dots. If you like to write it the other way, it's -4 is less than or equal to x, which is less than or equal to +4. So coming up the y, it first touches here, and it last touches up here. So we're going to go from -2 to +4. Okay, so I'm on the bottom part of number 2, where it just gives you the equation. You have to find range, domain, and a function. So right away you should say, heck yeah, man, this is a function because it's a parabola. So if I were to draw a sketch of this parabola, what would it look like? It would look like, here's -1, and it would open downward. So that's just a rough sketch, give you an idea of what it looks like. So let's talk about range and domain now. If I were to talk about the domain, we're talking about the x values, right? So going this direction, going across our x-axis. So because this line here will go on forever and ever, right? And this direction is positive and this direction is negative, our domain is all real numbers. Our range is a little bit different. So our range is talking about the y values. And so it does go on in the negatives forever, but it stops here at -1. So we have our range, our lowest point is going to be -infinity, and the highest, or the largest point, I should say, I guess, is going to be -1. All right, so this is a square root graph. So yes, we know it's a function. And let's talk about what it looks like. So it's going to be, here's our graph, and we have x plus 1, or x minus 1, sorry, under the square root. So if you think about the square root symbol, you can never have a negative underneath. So can I put 0 in there? I can't put 0 in there because then I would get -1 under my square root, which can't happen. So if I put 1 in there, 1 minus 1 is 0. So we know that 1, the graph starts. So, and then it's this curve, and it'll continue to go up. Maybe not as steep as I just drew it, but it'll go up. So let's talk about domain. Crossing the x-axis, the first point it hits is 1, and it'll go on forever. Let's talk about range. Range is coming up the y, and the first time there's a y value is right here at this point, which is 1, 0. At that point, my y value is 0. So my range starts at 0 and goes to infinity. This is number 3. It says find the value of the function for each input. So if I put -5 into this equation, what do you get coming out? So let's look. We have -2 times -5 squared minus -5 plus 2. So let's start with our parentheses and our exponent. -5 squared is positive 25. 25 times -2 is -50. A minus a -5 is positive 5, and then plus a 2. So your answer is -43. All right, this one stumps some people. This is saying that the function is equal to 7, not x is equal to 7. If x was equal to 7, there would be a 7 right here for x. So this is saying that 7 equals the square root of x minus 1. So what do you do first? You should square both sides to get rid of your square root. When I square 7, I get 49, and that's equal to x minus 1, because the square just cancels the square root. So then I'm going to add 1, and x is 50. That's your final answer. Okay, so let's talk about the questions on the back. Number 4 is y equals negative the absolute value of x minus 1. So when you see a graph that has absolute value bars, you're always going to get some kind of V shape. So when you graph, if you don't come out with a V, then you need to put some more values into your table so that you can get the V, because you need the vertex and you need intercepts. So you need to make sure that you have that entire V, including the vertex. So this one's upside down because in the equation there's a negative sign. So you can get negative in your table values because after you take the absolute value of a number, it's going to switch to the negative, okay? So the shape of this is an upside down V. The domain going, left to right is positive and negative values, and it's going to approach negative infinity and positive infinity because the arrows will keep going, okay? So this arrow and this arrow will keep going. This, over here is the positive x's, and these are the negative x's. The range is a little bit different because it doesn't go past the x-axis. And we know that when it hits the x-axis, here, that the point is 1, 0. Our y value being 0, so that's where it's going to be its highest. So it's going to reach going down, it's going to go forever, so that's negative infinity, and then the highest point will be 0, okay? So the intercepts are where it crosses the x and y axis. So let me erase some of this. So let's talk about those points. Where it hits the x-axis is right here, and that's at 1, 0. Where it hits the y-axis is right here, and that's negative 1, but it's 0, negative 1. Some of you switched that up. So then it has a line of symmetry. By line of symmetry, I mean, can I take this graph and fold it on top of each other, and will it match up exactly? So our line of symmetry is right here, where the vertex is. I didn't show that very well, so let me erase that and use the pencil. So right here, and that is at x equals 1. So yes, it's a function, and the vertex is the same as that x-intercept at 1, 0. So then you can see kind of the points I put in my table to help me get that V shape. I also know that it's a V shape, so that's what you should be getting. Last and final question. So it says graph the equation, the cube root of x minus 8. So the minus 8 part tells you where it hits the x-axis, and that is right here at 8. So at 8, 0 is my intercept also, okay? So then you kind of have to play around with it. What numbers can I put in to this function and be able to get out in a nice way to graph, okay? So we're talking about a cube root. So when we talk about a cube root, we talk about perfect cubes, okay? And so 8 obviously is a perfect cube. So if I put, if I need to get 8 underneath, what can I put in? That's what you want to ask. So you also have to remember that you can take the cube root of negatives. So if I put 0 in this graph, 0 minus 8 is negative 8. The cube root of negative 8 is negative 2. So that gives you your other intercept right away, okay? 0, negative 2. There is no line of symmetry because I can't fold it on top of itself. You could put a couple more points in if you want, but just note that a cube root, so cube root of anything is always going to be this weird S-shaped graph, whether it's exactly switching on the y-axis or not, depends on if you have adding or subtracting underneath your square root symbol, okay? So the domain, let me get a highlighter here. The domain crossing the x, this arrow is going to go on forever, this arrow is going to go on forever, negative infinity to infinity, okay? Because those arrows are going to go on forever and they're gradually, this one's gradually going down and down and down, and the other one is gradually going up and up and up, our range is going to be the same. So instead of writing negative infinity to infinity for both of those, I could write all real numbers. Okay, remember you can take the cube root of a negative, so there's nothing you're restricting yourself from putting into that cube root. All right, yes, this is a function, and there is no vertex. So the only graphs that have vertexes are the absolute value graphs and the parabolas.